class number two of our Reptiles of New Hampshire course. Nice to see you all again. Thanks for coming back for another edition. And today we are going to dive into the world of snakes, which is a group of animals I'm very passionate about, that I have loved since I was a very small child. I was one of those kids that could never have cats or dogs because my mom had allergies. So my love of herps, reptiles, and amphibians really blossomed from a young age. Dinosaurs sparked me, and then quickly realized, oh, there are things like dinosaurs that are still alive that are really cool. And I started finding snakes, garter snakes, where I grew up in Boulder, keeping them as pets, ribbon snakes, gopher snakes. And, you know, as I started to get into, as a elementary school boy, realizing all these, snakes were in the pet store, I started to get my eyes set on a ball python as my new pet. So I researched, I wrote up literally a document of how I could take care of it for my parents, sort of showing how responsible I would be. And I got a ball python in 3rd grade, and he was my snake for many years. I had him up through college, and was a snake that I would say really was a wonderful ambassador of the snake world. He was just so mellow and so relaxed, and quite a few people that said they were, fearful of snakes met him even when I was a little kid growing up, and, family, friends, and things, and really kind of changed their perspective a little bit about, their relationship with snakes and their fear of snakes. And that's one thing I want to address a little bit today with our snake themed topic, the human relationship with snakes, how complex that can be. If we have time, I'd even love to go in a little bit of some of the, the evolutionary history or psychology of that, but I do have probably more information planned today than we can fit in. So if we run out of time, I have the PowerPoints that I will share with you all that has a lot of great information, hopefully great information, about our topics for today. And I do want to try to see if we can get a lot of information in, because the world of snakes is just huge and fascinating. And I definitely want to get into the native snakes of New Hampshire and, kind of give a little introduction to all of our species that you can find in your backyards or in your local woods. And we will have a special guest today, so I will not forget that at the end. And time will tell who knows, it might be my dog. We'll see. Probably not them. So I'm going to go ahead and get my PowerPoint set up if there are no more questions. So today we are going to be talking all about the world of snakes in New Hampshire and beyond. So again, there's a lot of info today, and I'm probably going to gloss over some things on some slides. I'm not literally going to say everything on every slide. There'll be some details that I hope if you are interested, you can definitely go back and read it later. So I want to maximize our time and kind of keep things moving so we can introduce a lot of topics. But once again, you can read this later, and if you have questions that come up even later on, please just email me, or I'm happy to respond as time allows. So without further ado, let's talk about the world of snakes. Here's a little ringneck snake. This is a little hatchling one that I found a few years ago. So it just goes to show how small and even fragile some of these native species can be. These are ones that are very common. You can find in your gardens, under logs and rocks, and that little ring neck is the distinctive sort of thing to look for. But we'll get back to our native species of snakes a little bit later. So let's dive in. Oh, there's a vine snake I found in Ecuador when I was in Ecuador once, and looks a little intimidating, has its defensive posture. People see snakes, they kind of rear up, they open their mouths or hiss or look scary. That is a defensive posture. That is just a way of saying, leave me alone, don't mess with me, like, let's just move on our way. And really fundamental fact about snakes, they don't want to go out of their way to mess with you. They are generally very shy and secretive animals for the most part, and they really have no interest in unnecessary conflict. So even though this is a scary looking snake, number one, it was not a dangerous snake. I did end up catching it gently and calming it down after the photo, but looks scary. But again, we all have these kind of, not all of us, many of us have these triggers by these images of snakes, or kind of these ideas about how what they represent or how scary they can be. So we'll get into that a little bit later, I'm hoping. Let's quickly review what snakes are. We talked about this last week, kind of what it means to be a snake. What are these features, these characteristics they all have in common? So snakes, kind of to review, they're basically just lizards. They're basically just one offshoot of the lizard group, the squamates, squamata. So you can just think of snakes as one really fancy group of lizards that just took leglessness to the extreme, and a bunch of other cool adaptations too that go along with leglessness. So here are their shared derived characteristics, or synapomorphies, if you want to be really evolutionarily, technical. But they're legless. No snakes have legs nowadays. They have the elongated torso shape. They are all carnivorous. There's no vegetarian snakes on the planet. One way or another, they're eating prey. None of them have eyelids. Every true snake has that spectacle I mentioned to a few of you earlier. So a fixed scale over the eye, and they cannot blink. So if you see something wink at you, it is not a snake. It's got to be probably a legless lizard or something else. No external ears, we mentioned that. No snakes have any openings in the outside of their heads for hearing sound waves. Rather, they are focused on sensing vibrations through their jaws. And this is, we'll kind of review their evolutionary history briefly, but it's all about being from a burrowing ancestor and being able to detect their prey in an environment where really hearing isn't very helpful when you're underground. More the vibrations is a lot more valuable, and you don't get stuff in your ears when you're digging around too. Highly mobile jaws. We talked about how all the squamates, lizards and snakes, have that special sort of evolutionary common feature that has allowed them to evolve into all sorts of niches and have all kinds of specialized diets. And for snakes, that is extremely important for their lifestyles and their leglessness, as we'll talk a little bit more about. Snakes all have forked tongues to collect chemical cues, to basically smell their environment. That is a very important thing, that any snake that you observe in the environment, take and notice what it's doing. And if its tongue is going in and out, that means it's engaged, it's active, it is taking in information. If it's not moving its tongue, it might be sleeping. It's hard to tell when a snake is sleeping because its eyes don't close. But if it's just sitting there and there's no tongue movement, it might be taking a little, sort of Zen-like snake snooze. But tongue movement is a sign of engagement. That's how they find their prey. That's how they can detect water, all kinds of important things in the environment. And then venom production. We're going to hopefully have time to talk a little bit more about some venomous species, and even how a lot of species traditionally considered non-venomous do have some toxins that they use. And that's kind of a new idea about how we understand snake feeding behaviors, even some very common species. So.
Oh, I had a question.
Yeah.
In that last image, it looks like they have nostrils.
Okay, they do have nostrils. Yep, snakes do have nostrils for breathing oxygen. That's important. So,
okay.
all vertebrates. Let me say, do fish have nostrils? That's a good question. I got to ask an ichthyologist here. Certainly, all tetrapods. What I'm going to say, amphibians, snakes, birds, and mammals have nostrils for breathing oxygen. It's a shared.
Okay, so they don't use it for smelling. They use the tongue for
collecting. Yep, and so they don't have the same type of sort of olfactory processing systems as mammals do, for instance. And instead, they have what's called the Jacobson's organ, which is this little groove in the top of their mouth, and they pick up information with their forked tongue. 2 prongs means they can tell if it's coming from the left or the right. Very helpful if you're at a fork in a burrow and you're trying to figure out where your little mouse prey went, and then they pull back in their mouth. They, flick that information, those chemical cues in the top of their mouth, and that Jacobson's organ connects right to their brain. It's a whole different evolved system than the olfactory systems that mammals have evolved, but the same idea. You're just trying to collect chemical cues about the environment, process them quickly, and know how to respond quickly to, find prey and other basic needs. Does that answer your question?
There is another question.
Great.
Of convergent morphology. It seems like a lot of other animals kind of mimic snakes, and someone asked, what can we know about a turtle with a long snake neck?
Ooh, okay. That's an interesting question. Snake neck turtles. I would say that is extremely, they are very distant cousins. I mean, we talked about reptile, evolutionary trees last week and kind of how ancient that goes. And turtles and snakes have a very ancient common ancestor. So I will say, certainly within the squamates, the lizards and snakes, there have been independent evolutions into the limblessness and leglessness and elongated bodies many, many times. It's not just snakes. We talked about last week all these different realms of limbless lizards and that weird little 2-legged Mexican burrowing creature lizard, ajolote. It didn't just happen once within that little clade of the squamates. As far as, turtles go, that's, I think, a very different evolutionary pressure to have a long neck. That's, snakes, we think, evolved the skinny body shape to be burrowing animals and to basically get into burrows and follow rodents and to not have any kind of hang-ups on their ability to navigate that realm. And they've since radiated into, as we'll talk about, all kinds of other habitats. Snake neck turtles, I think that would be much more about catching prey, is my guess. I can look into that for sure, but having a long neck that you can, dart out real fast, I think is great if you're a fish hunter and want to just snatch up your prey real quick, much like a snapping turtle would. So that's my best off-the-cuff answer for that. Cool. Ready to move along? All right, hold on here. Let's go on to our next slide here. So we're going to quickly talk about, once again, the squamates, which is the group of snakes and lizards. And there's a lot of information on this slide. Once again, don't get hung up on all the details, and maybe some of the vocab will, try to make it clear, but I don't want to get too bogged down with our time. So again, it's a very successful group of reptiles, the squamates. They're the most species-rich group of living reptiles today. We have over 20 families, 500 genera, and 3,400 species that we have currently recognized, probably more that we haven't found in some of the rainforest habitats of the planet, most definitely more. And there are, for sort of reference, there are 10,000 species in the order Squamata, all the snakes and lizards, compared to 162 species in the order Primata, which is ours, the primate order, the mammals. So just, a little perspective there. Squamates are very successful. This whole strategy of having this uniquely hinged jaw, of being able to, eat specific prey, of having, of course, the ability to, inhabit lots of different habitats, even dry habitats, because they have, the shelled eggs, they're amniotes, like we talked about, and they have the scales. That has made them very successful. It's a very good strategy for having radiated and diversified into many species, more than any other living reptile group. And also for reference, 375 species are considered dangerously venomous. And I'm hoping we have time to get into the whole story of venomous snakes and how that's affected our relationship with them over, all of human history. And we'll see if we have time for it. We might even squeeze into next week if we need to for telling that story, because I think it's one worth telling. These squamates, snakes and lizards, they've colonized every continent on Earth except Antarctica. But in the past, they used to live there until it became very, cold. And they found fossils of reptiles and squamates there. And many islands, the exceptions, I find this interesting. We always hear about, Ireland, the story of St. Patrick who drove all the snakes away. And there's just so many myths and stories about snakes that have been woven into so many cultures, which I find fascinating. And, so just a little reference here. Here are the actual places that snakes never inhabited for the first place because, they're not real good at traveling. I mean, they're not exactly long distance movers. And, some of them have made their way to islands on, debris and things like that. But for the most part, snakes, there are places they have not been able to inhabit naturally. Humans brought some over, but, places Ireland, Iceland, Greenland, New Zealand, Hawaii, and some other islands in the Pacific, including notably Guam, never have had native snakes. They just never made it there. But they have found their way there to many of those places today. Hawaii, certainly, and definitely Guam have snakes that have been introduced, and these are, in the case of Guam, there's a very invasive snake there, the brown tree snake from Australia that's made its way there. So we won't get too deep into the weeds about that right now, but effectively, it's good to remember that these are, even though it seems like a limbless design is kind of limited, it's actually quite, good at having lots of variability and ability to navigate and colonize different habitats and different conditions, and even sometimes take advantage of brand new habitats that humans introduced them to. The brown tree snakes in Guam basically have wiped out most of the native birds because they showed up and these birds didn't know how to deal with snake predators, and they ate a lot of birds and they're still there today. So, in review, they live in a wide range of habitats. They live in rainforest canopies, deserts, oceans, wetlands, suburban neighborhoods, probably your own backyard in a lot of cases, Arctic tundra, and burrowing in the soil. There are still many snakes that are burrowing species, and that's kind of a throwback to what we think the common ancestor was for all snakes. But again, that's a little bit open to debate. So moving right along, we're going to show you the global distribution of snakes to sort of throw home just how widespread they are. You can see they're in all the continents and the oceans because we have sea snakes that are living out there in the open ocean, which is pretty amazing. A snake that, an animal that evolved as a little burrowing creature has become able to survive in the open ocean. It has had all the basic adaptations it needed to take this next step and exploit a new habitat, which I find pretty incredible. And here's just a quick overview of some habitats. There's an emerald tree boa from South America, a great arboreal species. There's many snakes that are excellent climbers, and certainly the rainforest canopies of the world harbor countless species of snakes. Here we have a desert species, a sidewinder viper, that iconic movement that it has over the dunes. So incredibly harsh habitat where not many vertebrates can survive due to lack of water. Snakes do not need much water and do not need much energy. We'll talk about that a little bit more too. So they're pretty good at, using these, harsh habitats, but just making do with what they have, with the limited resources they have. And here's a sea snake. I've always wanted to find a sea snake. I've never seen one in the wild, but here is, I believe, a banded crate, or what is it called, a yellow-lipped banded sea snake. And these are snakes that live in the open saltwater oceans, and they catch fish. They are paddle-like tails, but they're still reptiles. They still need to breathe air, and they still need to lay their eggs on land, just like sea turtles do. So these marine reptiles that have evolved to inhabit a new niche, they still need to sort of heed their ancestral callings, and they cannot lay their eggs in the water. They need to have, open air for the oxygen to be exchanged through the, shells and the membranes. So very fascinating how they've been able to be so diverse, and yet they're still constrained to some degree by these, facts of biology of their ancestry. So snakes and turtles from the ocean, all reptiles need to lay their eggs on land. We all know the stories of certainly turtles going on land to lay their eggs on beaches, but sea snakes have to do that too. They often find little, secluded little nooks and crannies on, seashore rocks and things like that. But anyway, moving right along, here's a snake that lives very far north. This is a European asp, which can live in some very montane altitudes in Europe, and one of the sort of iconic venomous species in Europe. And here is a common New England species that you might find in your basement. This is a shot of a milk snake, an eastern milk snake, which is known to often be in human environments, basements, and barns and sheds. These are 100% harmless. These guys are hunting rodents. They are coming into your basement because there's probably food there, and they are providing free rodent control. So one thing I will reiterate, probably a number of times in today's class, is that at least here in the Northeast, we do not have to worry about dangerous snakes. It is just not a problem for us in this day and age. So we'll talk about the timber rattler and that story, and there is a venomous snake that's around and has been around for a while, but it's just not an issue for us anymore. I mean, maybe never was even in New England, to be honest. And milk snakes are often killed, mistakenly, thinking there's something else because they happen to be around human habitats. So I'll definitely drive home the point of how it's always worth looking carefully at snakes, and just knowing that in our part of the world, you don't have to worry about these dangerous snakes like you do in some other parts of the world.
John, we do have a question.
Yes.
About scale diversity. I think this was in reference to the sea snakes.
Yeah.
Are those scales different depending on the different environments that the snakes are living in?
Absolutely, and I'm going to get to a scale photo a little bit before too long here. Hopefully we'll get to it. So yeah, snakes have a wide range of scales, and they're all adapted to the different habitats, but they're definitely specifically designed for locomotion. So yes, sea snakes do have specific scales that help them with their swimming in that habitat. Cool. So let's move right along. Just a few of the, sort of world record holders to show the diversity of snakes in the world. Here's the smallest known snake species, the Barbados thread snake, only from the island of Barbados. When you have these island species, sometimes they can become miniaturized because there are just limited resources in space, and that's an evolutionary pressure sometimes for smaller size. These guys are little burrowing snakes. They're blind. They've got scales that are well equipped to help them navigate in the soil. And some of these little guys, these little thread snakes, have actually traveled around the world in potted plants, believe it or not. And some of these, plants that you get from even like garden stores or whatever that may have tropical origins, just like earthworms and some other invertebrates. There are some snakes, these thread snakes, that are so small that they've actually hitched a ride in the root systems in the soil of these ornamental plants as well. So believe it or not this specific species, but other thread snakes are actually quite widespread. And, you may not even realize it, but there are, some of these guys living in potted plants around certainly the US that people have no idea about or in their gardens. So it'll be interesting I haven't heard of any taking hold as a new, invasive or naturalized species, but it's interesting just to sort of think about how these things are moved around inadvertently. The largest recorded snake species is the reticulated python. So the longest verified length is 33 feet. There have been lots of contested records for larger snakes. But this is a constrictor, non-venomous constrictor from Southeast Asia, especially Indonesia. And, there have been lots of bounties for the largest snake in the world, and people will bring in skins. But one thing they'll do is they'll kill a snake and then stretch the skin out, because you can do that, and then say, look how long it is. So it's a bit contested what the actual record is. But apparently this is the longest verified snake ever found, is the 33-foot reticulated python. The heaviest snake species is one that's well known by most people, the giant anaconda of South America. And these guys can weigh up to, largest confirmed specimen, 215 pounds and 17 feet. That is a hefty snake. They are aquatic animals, so they can, have their weight supported in the water. And, they have all kinds of stories and wild legends about the anaconda, ranging from, 26 feet to over 40 feet. But again, lots of tall tales. If you really want to have a good laugh, sometimes I'll watch that movie Anaconda that came out, I don't know, back in the 90s with like Ice Cube, great actor. And just these movies that kind of show the popular idea of snakes. And, I'm going to say they're not good for the public, misconceptions about snakes. But for me, I can have a good laugh about them. And the idea of these anacondas being, these like 50-foot monsters, it's pretty funny. But it does kind of capture a little bit about what a lot of people think about these snakes and their kind of imaginations, without really knowing these details about what they are, what are the records, and how do they live, how dangerous are they? And the answer is, for the most part, not very dangerous. Anaconda is really, there's very few. I'm not even sure there's any documented encounters of them attacking people. They really are, pretty elusive aquatic species. But I will show you this image here of some Amazonian tribes people carrying an anaconda. What I read about this is they were not, killing it, but just moving it out of their local fishing grounds. So, there's people that have lived with this animal for, many hundreds or thousands of years, and just sort of cohabitate with it. And most of us don't live alongside with large constrictors these days and age, but there are people that still do. Largest known snake of all time, a prehistoric creature called titanoboa, known from fossil remains, could grow up to 48 feet and weigh over 2,500 pounds. So we do not have today alive anywhere near some of the record holders of the prehistoric snakes. So titanoboa is currently the record holder, but there can be bigger ones in the fossil record we just haven't found yet. We talked a little about the evolutionary origins of snakes last week. I'm going to skip through some of this pretty quickly, but I just want to show you some pictures. I talked about how it's pretty tricky to see how snakes evolved because their skeletons are delicate. They don't easily fossilize. And, some recent discoveries have kind of given us some new ideas of when and how snakes evolved. The currently oldest described snake fossil is about the mid-Jurassic, about 167 million years ago. There's a lot of controversy, and it's definitely an incomplete record. So here we have the holy grail of snake fossils, the four-legged snake, excuse me. You can see very carefully, if you look at this fossil, there are little back legs. So this is really the evidence that shows that snakes used to have 4 legs. They all evolved from a lizard-like ancestor. And, every single snake today, kind of was part of that evolutionary pathway from legs to no legs. So evolution doesn't always go from simple to more complex. Depending on the circumstances, it can become simplified in some ways because that makes more sense for the situation at hand. And there's the other set of limbs there you can see. Here's some artist depictions of some of these prehistoric snakes, just kind of very small legs that were kind of on the pathway to becoming completely limbless. Speculative, but still pretty interesting, thinking about how they might still been constrictors, and but just, were on this sort of slow stage of losing their legs entirely. And there's another one there from 155 million years ago, Diablophus in a Tyrannosaurus skull, pretty epic. Some people think that some ancient snakes might have been more aquatic, and that was a big theory for a while, that maybe they were swimming rather than burrowing. It's a whole nerdy snake thing if you want to get into it, but basically you can read this later if you want to. Two strains of evidence about how snakes evolved, whether it was water or burrowing. They think it was burrowing from what I've read in recent studies. So I'm gonna keep moving on. The basic challenges of becoming a carnivorous tube, as I like to say, which is what a snake basically is, all their anatomical features have to be adapted to this body plan. So everything about a snake is really designed for this slender body and a lifestyle without limbs. So they, among other things, are the great energy conservers. I mentioned this, of the vertebrate world. Snakes do not need to waste energy if they don't need to. So, most ectotherms, reptiles, kind of have this strategy in their favor, where they can really not need to eat as much as mammals and birds and endothermic creatures do, because they don't need to keep those engines running to keep their body temperatures up. They can really just wait things out. And if a snake doesn't have enough food for months, sometimes it can be just fine and just wait it out and not waste energy until the right situation, the right food comes along, and then they'll take advantage of it. So infrequent meals, and again, harsh habitats, unpredictable food availability like deserts. This is a great, sort of set of adaptations to have if you're going to live in a place like a desert, because you don't need to have food every day. You might have a little, kangaroo rat come along every 3 weeks, and that's all you need if you're a certain sidewinder out there. That's all that, and they can get a lot of them, their moisture from their prey too in these deserts. They don't even need to drink. So pretty good at conserving energy and resources. Let's talk about snake skeletons briefly. That's always something I love to remind students, is that snakes are vertebrates. They do have skeletons. They are not worms. And they're simplified skeletons, but they're also amazing with their unique adaptations. It's basically a skull, and the hyoid is the connection bone to the vertebrae. And then you have all the vertebrae and the ribs. And that's pretty much a snake skeleton. But up to 400 vertebrae in some species, which is a lot more than we have, which allows for great flexibility and definitely allows that constriction behavior that many snakes use for killing their prey. And then we can see the jaw bones on that lower image there, and how snakes have independently moving jaw bones. So if you're feeling like it, you can literally touch your chin right now and feel how your two lower jaw bones are connected. They are fused in the middle, like all mammal lower jaw bones are. And you can see in our image there that is not the case with most snakes. They've got independent jaw bones that can move and stretch and allow large prey to pass through their mouth and their throats, which is a very important adaptation if you are limbless and a predator, because you can't cut your prey up. You can't slice it into little pieces very easily or chew it up. You have to really just swallow it in one whole go. And that's what snakes are really good at. And those jaw bones and the elastic ligaments that connect them are crucial for that ability. Quick overview of snake internal organs. I used to do snake dissections when I was working for an outdoor education organization. And, it's a pretty fascinating thing to see how snakes' insides are organized. And they have all the same basic, vertebrate organs that are all part of all of our shared, historical lineage. We all have common ancestors, all as vertebrates. So we all have hearts and lungs and livers and stomachs and intestines and bladders, all these things that you'll see in any human anatomy course. But the snake body plan is pretty interesting because they are tubes. So we have their long expandable trachea, which allows the accommodation of their big prey, and their stomach, of course, needs to accommodate their huge prey. So everything is very stretchable and elastic. They've got no diaphragm, which means their heart doesn't get compressed, because if we tried to swallow something too big, our heart would get compressed by that prey item and we would have a heart attack and die. It couldn't pump blood anymore. But snakes are able to basically shift their heart to the side because the diaphragm doesn't impede it, and that allows the accommodation of their large meals. No big deal. Some snakes actually, believe it or not, their heart will grow after they've eaten a meal so they can pump more blood to the stomach. They've shown how there's this, I think in pythons and boas, they've shown that can happen. Little tangent there. They have incredibly large livers compared to the rest of the body, snakes do, because they need to have a lot of very strong digestive fluids and acids for breaking down their entire prey animals, bones and fur and everything that they are digesting there. One of their lungs actually shrunken to the point of being like non-present and functionless because they couldn't have two. There wasn't enough room for the two lungs in the snake body, and one was enough. So we have that little mini lung. It's called the vestigial trait. And in evolutionary biology, vestigial is a sign of something from the past. And one other vestigial trait you can find in some snakes is little spurs on the base of their tail that are little remainders of the legs, the limbs they used to have thousands and thousands, millions of years ago. So one cool thing is the lung, though. And the kidneys are staggered. They have to be able to, once again, fit. But again, a lot of basic similar body, organs as any vertebrate. It's really just the same plan, just a whole new arrangement given their evolutionary trajectory and body shape. Other cool things about snake anatomy, they have their windpipe located in the front of their mouth. You can see on this tropical parrot snake, that little hole there. And that's not for the tongue. That's actually the breathing tube. And I've seen that when I've fed my python before, is while they're swallowing a prey item, you can see that little breathing tube poke out under the prey so they can keep breathing so they don't suffocate. So it's really important they're not just, having their windpipe blocked up by whatever it is they're swallowing, like we would have if we tried to swallow something that big. And most snakes also do have recurved teeth that curve back, that keep struggling prey from escaping. Because again, they're trying to maintain, grip on their prey. They don't have legs, they don't have arms. And unless they're very venomous and can bite it and then wait for it to die, they have to hold on to it and make sure it doesn't escape and either constrict it or just swallow it whole, pretty much and alive. All right, lots of stuff going on. Let's keep moving on. Again, if there's questions, I'm happy to stop. And if we don't get through everything today, I think what we'll do is we'll probably just pick up where we left off next week in addition to our turtle lesson. But I got a lot of fun things to say about snakes, so hope it's all worthwhile here. Let's move on to the sensory perceptions of snakes. We talked about their ability to smell and taste the air effectively. So they collect airborne particles on their forked tongue, and they chemically analyze it using their vomeronasal organ. Actually, I was wrong when I called it the Jacobson's organ. I forgot that it had been renamed. I guess Jacobson didn't deserve the title or something. I don't quite know the story there. But it's the vomeronasal organ on the roof of the mouth. So basically, they can just flick their tongue out, collect some little particles in the air, pull it in their mouth, and then they can put that into this little Jacobson's organ. Here's the old name, but they put that in a little groove there, and that goes directly to the brain. And the brain processes that like chemical information and then can respond to what it means. And like I mentioned, the forked tongue allows them to, quote, smell in stereo. They can pretty much say, oh, do I have more particles of mouse on my left fork of my tongue than the right? Ah, I shall turn left at this juncture in the tunnel and find the prey. So it's just a great way to be able to track things that way. Snake vision. Snakes have what I would say is decent but not phenomenal vision. They're pretty good at tracking movement, and some species way more than others. And you can see a range of snake eye sizes and designs there. And some basic things to think about is arboreal snakes, the ones that are hunting in the trees, tend to have the best vision, like these big cat-eyed snakes that you'll find in the tropics, like the one in the middle there. And then you also have snakes like the burrowing snakes where the eyes are useless and vestigial. They've lost their vision because they don't need it, just like a lot of burrowing creatures like this worm snake you have at the bottom there. So it's kind of a wide range, but no snakes rely on their vision primarily for their, well, I don't know. I mean, maybe it's arguable for some of these tree snakes, but I would say the scent is always as important, if not the primary way they find their prey for a lot of our native species. One interesting fact is that nocturnal snakes tend to have the slit cat-like pupils, and diurnal snakes tend to have the round pupils. So that's just a way that you can collect more light as a nocturnal creature. If you have those slit eyes that can really contract in the day so you don't have too much light coming in, then they can expand hugely at night to really get the most light possible. So some little things to think about when you're observing snakes.
Is that also an indicator of a venomous snake, the slit?
No, there are snakes that are not venomous that have slit eyes. So that is not a good diagnostic. I would say North America, we tend to think of like rattlesnakes as being the slit-eyed snakes, but I'd say it's really not a helpful characteristic because as soon as you go in the tropics, it's really all out the window. And yeah, there's other things that are better characteristics to differentiate venomous versus non-venomous. The head shape primarily here, and we'll talk about that because there's literally only one venomous snake around our neighborhood, and it's pretty darn rare. So hopefully we'll get to that soon. Check our time here as I am trying to inevitably pack in too much information. So other sensory perceptions, like we mentioned, snakes, they don't hear through the air. They have their flexible jaw bones. They can feel vibrations. And like I mentioned, actually I haven't mentioned this yet, some snakes have independently evolved facial pits that can detect infrared thermal radiation, basically heat. So they can literally see the heat of their warm-blooded prey. So we've got the pit vipers. Here's a rattlesnake. This one I think I saw in Texas, Big Bend a few years ago, a black-tailed rattlesnake. You can see that little pit. There's the nostril on the top and that little pit kind of underneath it between the eye and the nostril. And that is the pit that gives the pit vipers their name, that senses that radiated heat. And they can actually then sense their prey in pitch blackness, even without smell, without eyesight. And that's still an extra set of cues. And on the left, you can see some other snakes have independently evolved this, like this python, African green python there. My ball python, Frank, also had those, even though he probably didn't need to use them very much because I would feed him his dead rats. But here's kind of what the idea is, they can see the heat, just kind of I call it predator cam with kids, that sci-fi movie with the alien that could see the heat of its human prey. That's basically what these snakes can do, is they can just sense the heat of the animal. And that is really good if you're hunting warm-blooded prey, because that is going to be a really distinct change in the environmental cues when you see a warm-blooded mouse crawling by, probably more helpful than just sight or smell if you're living in a place where it's super hunting when it's dark and might not have time to smell it as it's coming up. So that's a pretty cool ability. Oops, that many snakes have, but certainly not all. And we mentioned scales. Someone asked about that. Let's show quickly some of the variations of scales that different snakes have. So all reptiles have scales. For snakes, they're very important adaptations for water retention and protection, and definitely for locomotion because they don't have legs. So the shape and arrangement of scales are very important for how they move and can help you to identify the different family groups. So we've got what we call granular scales at the top on this file snake. We've got the bottom left. This is actually a helpful thing for New England snakes, whether scales are keeled or not. So keeled scales, they have that little ridge along the middle of them. And there are a number of species that have keeled scales here in New England and a number that don't. So you can see a milk snake on the right that has the smooth scales and a rattlesnake on the left that has keeled scales. But once again, it is not an indication of it's a rattlesnake or venomous. There's many non-venomous snakes that have keeled scales too. And I'll get into some more details about some of our native species, but with any field guide, it'll tell you, oh, it has keeled scales or it has smooth scales, and you're trying to identify a snake. As I mentioned, I showed some snake skin earlier. Snakes can shed their entire outer layer of skin at once. They have to sort of use their environment to rub it off. Their little spectacle scales that cover their eyes will come off with their shed skin. So whenever you find a snake skin, kind of look for that and kind of a little indication of it was a good shed for them. They were able to get it all off their bodies entirely. And it's called ecdysis is the technical name for this sort of unique style of shedding that snakes do. It's like pulling a sock inside out, basically, as they're pulling it off their bodies. And snakes tend to shed 1 to 5 times a year. It varies a lot depending on the age and species. But younger snakes do tend to shed more because they're growing faster. So they need to sort of, release this old constraining dermal layer, and they grow a new one underneath before they shed it. And that way it can accommodate the growth. I mentioned about the eye scales, and they do become opaque prior to shedding. They kind of become bluish. And for my pet snakes, I've always noticed that, you can see them when they're ready to shed. You want to make sure they stay nice and humid during this time so they can have the right conditions for good shedding. And you don't want to really maybe mess with them because snakes are known to get grumpy when they have this opaque coloration on their eyes because they can't see. So it behooves them to be a little more likely to strike because they're just not quite sure what's going on. They don't have as much information about the environment. So that's one thing to be careful if you find a snake. If it has the opaque eyes, maybe give it a little space. You never know how grumpy it might be. Mentioned about locomotion. So snakes, they're very good at moving all over the place. They can climb, they can swim, they can do all kinds of things. But their belly scales are especially important for the terrestrial species. They have those specialized overlapping belly scales that always overlap towards the back. So they have that friction and they can stretch their muscles, expand and contract, as well as different types of motion. And that always allows it to catch on little bits of friction in the environment. And if anybody's ever tried to catch a snake in the sun and had to get away from them, you can know just how good this style of locomotion can be. I mean, it's always kind of remarkable to me how a limbless animal can move so incredibly fast. And we'll talk about some of the world record holders for snake speed, I think, a little bit later. But it's a pretty good system for locomoting if you are limbless.
John, we have a question.
Yeah.
The shedding the skin, actually. How long does that process usually take?
I would say it varies, but like a few days to a week would be my sort of armchair estimate for how much time it would be. Yeah, but it depends on the species. So pretty much you'll see the snake kind of slowing down, staying secretive, if you have a pet snake, I should say, and the eyes get cloudy. And then usually within, probably like 4 days or so, it'll probably shed. But again, it depends on a lot of different environmental conditions. The different locomotion styles, I won't go to all of them. You can look at this later, but you can just see all these different ways snakes can move. You kind of have the sidewinding style, which is really unique for desert snakes. But around here, snakes will both be able to move in this sort of concertina, kind of like an accordion opening and closing movement, but also the serpentine movement is they're kind of bunching and contracting their muscles. So, I mean, with my python, I used to have literally, it could just be, in your hands and kind of bunch its muscles and just kind of escape and, expand and contract. And they can just move in a straightforward line that way, just with their muscular movements and then the scales to, push against the, friction, in the environment. So I'm not going to go into all that. Let's move along. You can look at that later. Winter dormancy. You can look at this also a little bit more later. It's about how a lot of snakes will hibernate in dens, and garter snakes especially have very large dens. I sent you an article about sort of this communal hibernation behavior and how they all merge, these garter snakes, in places in Manitoba in these incredible numbers. But the word for reptile hibernation, if you want to be more fancy, is brumation. So all of our New Hampshire animals, they go into brumation, New Hampshire reptiles, I should say. And, you know, their metabolism slows down when they can't find food and there's not the right temperature to continue to be active. But turns out most snakes stay somewhat active in the winter in their little hibernation chambers called hibernacula. And they do need to actually move and drink occasionally. It's not just a complete kind of a, you know, extreme hibernation like you think of with a lot of animals. They do need to have that ability to sort of stay, keep access to liquid water. And that means, as I'll mention, staying out of the frost zone. But a lot of snakes will all come to the same places because those are the good conditions for a snake to hibernate, where they can have these conditions. It's not because they necessarily want to be social. It's really because it's just the right conditions, and all the snakes hone in on the same places. And a lot of snakes have these communal hibernacula because of that reason. So the basic thing about reptiles and amphibians in winter is you got to get below the frost line here in New Hampshire. You have to find somewhere you can hibernate where you're not going to freeze. There are some exceptions to that. Some of the amphibians we have around here, like wood frogs and spring peepers, but that's another class on amphibians. But, you know, snakes, turtles tend to go to the bottom of lakes. We'll talk about that more next week, but snakes need to find burrows or hibernacula for their brumation. And here we have another good example of a snake hibernation behavior. The red-bellied snakes are a very cute native species, and these guys are one example of snakes that have a mass migration in the fall to their choice overwintering sites, because they've all kind of learned / evolved where the good spots are. You wonder if there's even some, you know, sort of evolved memory there in their behavioral, you know, systems. It's hard to say, or they just learn over the course of their lifetimes. But they go to places like anthills and abandoned rodent burrows, rotting tree stumps, places like that, which are just really good for a little snake like that to have the right conditions for hibernation. And you'll often get many individual snakes of different species that will do this together in the winter in New England. You'll get Decay's brown snakes, ringneck snakes, smooth green snakes, common garter snakes, all together. And there have been some pretty amazing examples of where they found just tons of snakes. One anthill in Manitoba in 1932, they found 257 snakes in one anthill, including 101 red-bellied snakes. So it's a pretty extreme example, but it is one of those things that still goes on today. Absolutely, these little snakes will find the same sites because, once again, not because they're social or they want to hang out or stay warm. It's just the right conditions, and they all just tend to hone in on the same places.
How far are they traveling to get to these sites, John?
That is a fantastic question, and I don't know if there have been studies done on these small snakes for how far they will travel, to be honest. It's a hard thing to track snake migration and movement. There have been a lot more studies done on larger snakes, like especially timber rattlesnakes, which I'll hopefully get into either today or next week. But I haven't read about that, and my guess is we don't know a lot about it. And as a sort of basic response to that is there's a lot of things we don't know about even our native common snake species. They have not been well studied to a large degree. Quite a few of them, they're very secretive. They're hard to find in their habitats. We don't have a good sense of their behavior, their population size, how they're responding to modern threats of climate change and fragmentation. We just don't have the data. So it's kind of a mystery, but that's a great question. I don't have a great answer for you. I'll look it up though. If there's any information about it, I'll see if I can find it for next week. Quickly mention the common garter snake. I would say everyone, I hope, is familiar with this very, very common snake, the most commonly encountered snake in this part of the world, and also the most well-studied snake of all New Hampshire species because of how easy it is to find and track and observe. It's also the most cold-tolerant reptile in North America, and it can range all the way into Canada and Alaska for this cold-tolerant ability that it has. And during its brumation, it has, like all reptiles around here, they lower the metabolism, digestion stops entirely. And for that reason, by the way, snakes need to stop eating before they start getting ready to enter hibernation in the fall. So in the fall, they want to make sure they clear out their digestive system, because if they go into this brumation phase and they've got something, in their gut, that's going to start rotting and they can go septic and die that way. So snakes will definitely want to clear out all their digestive system and stop eating for a little while before they go into the hibernation phase in the winter. And like I mentioned, they will remain kind of sluggishly active in the hibernacula, and they do need to find liquid water to drink. So it's not just a complete, lack of movement or any activity. They do kind of, crawl around and need to stay somewhat active to survive. And I don't know how many of you got a chance to see that article and video I emailed this morning from the New York Times. you didn't today, no problem. You can check it out later. But there's some pretty amazing examples of these group hibernacula in garter snakes because they all want to find the best spots. The farther north you get, the harder it is to get below frost line. So the types of little crevices and nooks are going to be very, prime real estate for all the garter snakes in the area. And that's what you find in parts of Canada. So I'll go into these details later. I might skip over some things. But again, you have all these guys going to the same place. And in Manitoba, all these garter snakes are trying to find the same deep hibernacula. And it turns out they've done studies that a lot of them actually die every winter because of just how extreme the winters are, even up to one third to one half of them every winter. So they're really trying to get below frost line to escape that potential for freezing. And it's not a guaranteed deal by any means, given the variations of conditions every winter and certainly loss of hibernacula sites due to development, etc. And the really famous site in Manitoba, I think the article features that there are 70,000 garters estimated then together. And actually, I think, as I read, there was a big cold winter in 1999 that resulted in a major die-off of the population. So my guess is they've been boosting up their numbers since then. I haven't heard of the recent population estimates. But definitely check out that article, which includes some really cool videos of all these snakes emerging at the same time, like this. So this might make you squirm a little bit if you're not, really into lots of snakes. And I think we're not going to get to it this week, but I'm hoping we'll start next week a little bit more about humans and snakes before we go into turtles. Just trying to keep track of our time here today. This I find fascinating, this behavior of garter snakes. So the males have been shown to enter, generally speaking, they'll enter the dens first in the spring. And they want to get themselves warmed up, get their metabolism going, and they're ready to mate. They are ready to compete for a mate, and they need to be activated and energized and ready to take advantage of the females that come out before another male does. But what they found are some males will actually, in the process of emerging from the hibernation chambers, they release the pheromones of a female. And you'd wonder, why the heck would they do that? Why would they send out the message that, hey, I'm a female snake, when they're a male? And they've studied it, and the big answer to that, they think, is it's a way to get warm. So these are the late rising males that are coming out. Maybe they didn't set their alarm or something, and they're like, oh man, I got to get going. I got to find a female. Holy cow, all the other males are out. What am I going to do? Oh, I'll just put out this female pheromone. They don't actually think that, but here's how I describe it. They put out the female pheromone that convinces other males they're a female. So they come and then crawl over them and rub against them and warm them up in the process. So it's basically a shortcut to warming up in the spring. It's just a little sort of deceptive behavior that males will actually use against each other. They've evolved, which just was this ability to mimic or even sort of create a female pheromone. So pretty cool stuff. A little more about snake reproduction, which they generally do in the spring. It's an internal fertilization. So amphibians, they all have external fertilization. So do fish. But reptiles, I think pretty much exclusively have internal fertilization. The males use reproductive organs called hemipenes. There's two of them. And they do extend from what's called the cloaca. That's actually kind of an important vocab term in reptile biology. Cloaca is the vent. It's the the opening at the base of the tail where they pass their waist and where the reproductive organs are. And males will then use this during copulation. There's a lot of pretty complex courtship behaviors that many snakes have, all kinds of dances and little rituals, and a lot more complex than a lot of people would give credence to a reptile, with just how it's almost bird-like in some of the complexities of these displays that they'll have sometimes. And there's the hemipenes, kind of weird, but that's what they look like. All different kind of shapes and sizes, and they can only use one at a time. So why do they have two? Well, I guess it depends on which side they happen to be on. So moving right along. Again, there's some of the courtship behaviors some of these snakes have. Well, they'll this is some ritualized male combat. Actually, this is almost like bucks competing over a female in kind of a ritualistic way to prove who's stronger and who has the right to mate. So really just testament to, how complex the behavior of snakes and other reptiles is that we don't tend to give them credit for. We tend to think of mammals and birds as these very complex, intelligent, animals as far as their behavior goes. But snakes absolutely have some very incredible behaviors too. Some of the vipers do what we call topping. They try to curl over each other and knock each other over. And I'll totally find a video of that to send you to check it out, because it's pretty amazing to watch. What are we doing time? I definitely wouldn't even get close to all our slides today. So thanks for bearing with me. I hope it's all interesting. Getting into some of the snake biology stuff here. Here's some of the reproduction strategies that snakes have. Some questions about that before. Some snakes lay eggs. We call it oviparous. And the mother snakes in some species will stay with the eggs and protect them. Sometimes they leave them alone and let them hatch on their own. Some pythons even shiver around their eggs to actually create heat to keep them warm enough. So some pretty doting parental behavior in some snake species. King cobras actually build a nest and stand guard over their eggs, like a crocodile would do, or a bird. So pretty amazing. Hatching baby snakes do have to cut through their eggs with what's called an egg tooth. A lot of reptiles have that. It's a little sharp structure on their nose that they lose pretty quickly after they hatch, but it's a sort of helpful little tool to slip through that leathery shell and be able to escape. And really, snakes, once they hatch, they do not get any teaching from their parents. I think that's pretty much a universal rule as far as we've studied. Baby snakes go off on their own, and they have all the instinctual behavior they need to fend for themselves. And not to say a snake can't learn over the course of its lifetime, but does not rely on a parent to demonstrate any kind of behavior for it, like most mammals and birds have as far as the reproductive strategies. Some snakes are ovoviparous, which means the mother retains the eggs in her body until they hatch, but it looks like she's giving birth to live young. They come out, in the membranes. So it's a better way of reproducing if you're in colder climates, because it's easier to incubate the eggs in your body as opposed to externally, where it might be too cold. So a few snakes are what we call truly viviparous, which means they feed their eggs with a placenta in addition to a yolk sac, which is almost like stages to mammalian reproduction in the evolutionary sort of scheme of things. But this includes animals like anacondas and boa constrictors, other constrictor animals. On the bottom there's a viper species that I believe is a ovoviparous snake. A lot of our native vipers, rattlesnakes, and copperheads are ovoviparous. So a range of different strategies, pretty interesting, the different ways that snakes will reproduce. Some lay eggs, some don't. Some have what appears to be live young. Some snakes have asexual reproduction. They don't need a male to reproduce. In North America, we've got our copperheads and cottonmouths, two related vipers, and it's called facultative parthenogenesis, where a female can basically give birth to clones of herself without any male insemination. This is actually common in a lot of animals. The more we study about animals, the more, we find this to be an evolutionarily viable strategy of, you don't have the variation of different, genetic recombinations of having two parents, which means you have maybe more mutation potential for adapting to new changes in the environment, but you don't need to find a male. That's the benefit. So you don't need to worry about the uncertainty of meeting and reproducing with a male, and females can just give birth to clones when they want to. So it's a whole different reproductive strategy. Venom, I'm going to hold off on this because I want to get back to this later. And I want to just kind of move on with our last bit of time. Let's talk about the snake families. Let's go ahead and talk about this because it talks about the snake families a little bit. Venom, I think, is just a fascinating topic and really speaks to, I think, a lot of people's fascination / fear with snakes. And we're not going to have time to get all into it today, but we'll definitely continue next week. So just as a little heads up, we're going to stop where we stopped today. Hopefully have a little bit of Q&A, and then I'll pick up where we leave off for next week. And we will get into turtles then, as well as the rest of our snake topics next week. But I just had a lot of things I was excited to try to squeeze in today, and not surprisingly, didn't have enough time for everything. But in a nutshell, many snakes have evolved the ability to produce toxins and from specialized salivary glands. We've got the viper family, which includes rattlesnakes, and we're familiar with some of those that are North American species. And we have the Elapidae family, which is mostly old world, Asia and Africa, and that includes cobras and mambas. We do have coral snakes, though, here, which are elapids in southern parts of North America, certainly into the tropics. And different styles of envenomation. Maybe we'll get into some of the details of their teeth and how that works. But really, the bottom line is that snakes seem to have evolved toxins, venom, to target their prey. It's more about killing their prey than it is about harming, threats or, certainly people or predators. So really, that seems to be a secondary use of the venom, ability of venomous snakes, is they'll use it if they need to against something they're scared of, but really they're trying to just kill their prey and take them out quickly. It's a way they don't have to hold on to their prey for all kinds of reasons in different environments, like maybe a sea snake in the ocean or a tree snake. And there's a little eyelash viper in the top left in the trees. You don't want that prey to get away. It might be fast, it might be slippery, it might be able to jump, and you got to just take it out real fast. Having venom is a real good way to do that. So we'll get into some of these maybe venom types next time. I love the name, by the way, bungarotoxins, all these different types of chemicals that snakes use that target blood or the nervous system, hemotoxins, neurotoxins, and then bungarotoxins. I forget what they do, but it's just a great word. I'm going to move on. Here's yes.
And I know there's none of those venomous snakes here, but can you talk about some of the New Hampshire species?
Yeah. And, I'm so sorry that I didn't get to all that. I was really just I'm going to zoom ahead here real quick. I'm going to give you a quick overview of New Hampshire species before we are done today. And then I want to definitely pick up on that before it's, our class is over. So next week, I really want to get into our native species. And I think I just got a little carried away. But here's an overview of all of our native species in New Hampshire. Our species include red-bellied snakes, Decay's brown snakes, garter snakes, ribbon snakes, milk snakes, ringneck snakes, northern water snakes, smooth green snakes, eastern hognose snakes, black racers, and timber rattlesnakes, which is an extremely rare species, if not extinct, in New Hampshire now. And I definitely want to give you all a rundown of these species, and I think we're going to maybe even start with that next week. But before we're out of time today, I'm going to turn off my screen sharing, and I would like to show you a live snake, if you think that would be interesting, because I do have a little specimen here for you. And this will be a little intro to our native snake species. I caught this specimen on the summit of Thumb Mountain, which is right near the Hair Center in Hancock. It's a wonderful habitat for finding snakes. I've always been there with kids, and there have been skins all over the place. And I figured, hey, if there's one place to go where I could probably catch a snake, that's where it is. So I'm going to show you my new acquisition here. This is a milk snake, eastern milk snake. They are one of my favorite native snake species. They're just gorgeous, gorgeous snakes, and they're extremely mellow. I've never had a wild milk snake ever even try to bite me. This one, snakes do what's called, I call it skunking. They release these very potent smells from their cloaca, and it just makes you smell bad for a while. Garter snakes almost always do that, and definitely aggressive snakes like water snakes, if not even biting you too. But these milk snakes are just so calm. And this one, I'm not sure the gender exactly, but it's probably over 5 years. It's a pretty good size. Just a very healthy specimen here. And these are generally rodent eaters, but they'll eat a lot of different small creatures. And they're pretty well known among human habitats and environments because they like to hang out around people. And the name milk snake even is a testament to just sort of the myths and the stories that have been, circulating about so many species for so long. The story about milk snakes was in the old days, they said they'll break into your barn and literally latch onto the udders of your cow and steal the milk. That's why they call them milk snakes. That was the story about them, which is just utterly ludicrous, But they're in there to get mice. They are rodent control little agents. So they're only helping you out when they're around. They're entirely harmless. And these guys are often, misidentified as venomous. They're killed unnecessarily. And it's just so unnecessary and unneeded because they're just beautiful animals and so helpful. So I mean, honestly, I bet a lot of you may have seen these guys around your homes, and just leave them be. If they're in your basement, you can probably just pick them up and let them outside. If you're a little nervous, you can get a bucket or something. But again, 100% safe and beneficial. And I was pretty excited to find this little guy. So I definitely want to, who knows, by next week maybe I'll find another specimen, but hopefully continue to talk about some of our common native species of New Hampshire next week, and also get into turtles as well. So I hope you guys enjoyed our dig into snake biology and diversity a little bit. And sorry we ran out of time for all the things I was planning for today, but definitely want to pick up where we left off for next week. But I'm happy to stick around for if there's any final questions for a few minutes while we're together. I know we're reaching the end of our official time, but I'm happy to chat a little bit. If there's any more immediate questions that have come up.
On that milk snake, when I've seen younger ones, and they look like the bands were redder than on the one you just held up. Is that
yes? Many of our native snakes, the young, have very different patterns and usually brighter and starker than the adults. And the most dramatic example I would say is the black racer. Adults that are like jet black, and as little snakes they have these beautiful colored stripes because it's better. Kind of think of a baby deer. It's like better camouflage when you're young and vulnerable to have more breakup of your outline, I think is the idea. And water snakes too, and milk snakes, yeah, as babies they just tend to have these very like bright, kind of banded colorations, and as they get old they kind of get duller and a little less distinct. But I think the idea is that it helps them to be more camouflaged when they're little neonates and are more vulnerable. But I mean, it's a good thing to know. It really confuses a lot of people when they're trying to identify a snake when it's a young one. They're like, wait a minute, what is this thing? You know, it doesn't look like a black racer to me. You got to see the different stages. It's almost like looking at the larva or an adult of a moth. You got to know all the stages to know how to identify a species. You can't just think about it as one fixed coloration scheme, you know?
Thanks.
Yeah. Any other questions? All right, maybe we're all done for today. Miles, any last things you want to mention here?
I think we're all set. We had 20 people join today, so thanks everybody for attending, and we have one more session next week. Yeah,
cool. And again, if you have questions that come up, email them to Miles or me, and I'd be happy to either email you back directly or address it in class. And definitely want to get into our native species next week. So sorry if you didn't get to see all the snakes you're hoping to see this week, but I want to make sure that we cover them next week. So.
Okay.
All right.
Thank you so much. And also, if you ever are going to do like an advanced class or anything, like a part 2, I could listen to you talk about reptiles every day. It would be awesome.
Hey, just welcome to the inside of my brain, right? It's just about people. Cool. Thanks so much for joining us, everyone. And
Can I ask
our second class, and we'll be back next week. And again, I sent out some articles this morning, so check them out and try to send out some other things getting ready for next week. So please join us again next Thursday.
Okay.
Deb, if you had something to say, we're still.
Yeah, over the internet, my question about this long-necked turtle, they said run if you see it coming, and I don't know where it is and how dangerous it is.
As far as I know, what we call long-necked turtles are Australian primarily. They don't live around here. But I mean, we've got some long-necked snapping turtles that you might see around here. And as we all know, snapping turtles you got to be careful with, but they're not going to, you don't got to run from them. There's literally not a single reptile that you need to run from. None.
Okay. Thank you.
A good rule of thumb. Maybe a black mamba if you're in Africa, but that's, we'll talk about that.
Okay, thank you.
All right. Well, once again, thanks everyone for tuning in, and hopefully see you all next week.
Thank you.
Thanks, Miles.